Right, hello Year 11, this is practice paper set 9, paper 1H, which is a non-calc. Let's look at question 1. Look at this key bit of information. You must write down all stages in your working. This gives you the method marks. Right, question 1. Here's a hexagon and it says CD is parallel and you have to work out the area of this hexagon. So this is a compound shape. You should split this into 2 and I would split that right here. So one method mark is likely to be 14 times 20, the area of this rectangle. So that is 280. Now there is this trapezium here. So you want to work out this area, the trapezium. Now, if they give you this whole length of height up to here as 24, then you know the height of this trapezium must be 10. The formula for a trapezium is h times a plus b. A plus b are the parallel sides divided by 2, so the height is 10 times 16 plus 20 all divided by 2, which is going to equal 10 times what's in the bracket, which is 36 divided by 2, which is equals to 360 divided by 2. And I'm just going this way for room, equals 180. So you need to add those two values together to get that 0, 6, 1, so that's 460 centimeters squared. Okay, on to question 2 now. And we've got to reflect the triangle S in the line y equals x, label the new triangle R, and then translate the triangle S by the vector -4, -6 and label the new triangle T. So you're just doing 2 transformations on one page. It does name the triangle, so be careful with this question here. So first things first, this is the line y equals x, because if you can see this coordinate, it's 8, 8, and the y coordinate equals the x coordinate. Right, so when we're reflecting a diagonal, if you're going 1, 2 across, and this maps this point, and you must go 2 up. 1, 2. So that point will map there. This is going 1 up, so then you go 1 across. This point maps there. Doesn't matter which way you do this. 1, 2, 3 up, so I'm going to go 3 across. 1, 2, 3. That maps here, and you just fill that triangle in, and you label that R. Now the next step is to translate, and it does say go -4 left, because -4 at the top means left or right, and if it's minus and negative you go left, if it's positive you go right. So obviously something positive is good, or if it's right then it kind of makes sense, and that'll help you remember, and something negative is a bit down, so positive is up and negative is down. And remember, the question says do it from triangle S. So the most common lost mark of this is when people do the translation from R, but you've got to do it from left, from S. And here we go. So this, so remember the translation is 4 left and 6 down. So we count 4 from one point. 1, 2, 3, 4. 1, 2, 3, 4. 5, 6, that point maps there. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6. And you know the last point here will just map to the point you just did. You do fill that in with a ruler, label that T like the question says, and that's an easy 3 out of 3 marks. Right, here's question 3 now. Ali thinks that the value of e will be a prime number for any whole number value of n. Sometimes they might use the word integer. Is Ali correct? You must give a reason for your answer. So the best thing to do is just to substitute numbers for n. So let's choose n equals 5. So you're going to get 5 squared plus 5 plus 5, and then that equals 25 plus 10 equals 35, and 35 is not prime, so Ali is not correct. Question 4. Angles on parallel lines. It says find the size of angle ABG. It doesn't ask for reasons, so you don't need to write it. So angle ABG, which is this one here. So what's going to help us? These lines here, meaning that's an isosceles triangle. Now, if we combine 38 plus 65 here, that is 103. So this angle must be 103. There's more than one way to do this question as well. Now, if you think this isosceles, it is isosceles. What do we know about isosceles triangles? They have 2 equal sides and the base angles are equal. So that means this here must be 65, which gives us the angles in a triangle, 180 minus 2 lots of 65s, which is 130 equals 50. It's good to have some method marks here, just so you don't lose any marks, just in case you make a silly mistake. Now we know angles in a straight line is 180. So we've got 180 minus 103 minus 50, and that's going to equal 27 degrees. And obviously if the question asks for reasons, say angles in a straight line, alternate angles are equal, etc. And that should be done. That's a 3-mark question, quite easily done. Here the first 4 terms of arithmetic sequence. Find the expression in terms of n for the nth term of the sequence. So you could quite see clearly that it's going up in 4s. So if you write the 4 times table on top, that's 4, 8, 12, 16. We know it's 4n. Now how do we get from 4 to 6, 8 to 10, 12 to 14? Well, we just plus 2. So that sequence is 4n plus 2. Write down an expression for the n plus 1th term of this sequence. So this question might look quite difficult, but all it's asking you to do is to substitute the n for n plus 1, because that will give you the n plus 1th term of the sequence. So just do, instead of the n, write n plus 1 plus 2. You can expand that to 4n plus 4 plus 2, so that answer is 4n plus 6. Nice 1 mark there. Let's look at question 6. We're simplifying this, so let's do it number by number or term by term. So we've got 20 divided by 4 first, which equals 5. So you will get 5x squared. That will simplify to this. Now we know x squared divided by x squared, it does not equal 0, but equals 1. So that would cancel out, that would cancel out. And y to the 6th divided by y squared, we know we minus those powers, so that's y to the 4. So the final answer is going to be 5y to the 4. Make e the subject, so we minus f on both sides. We get h minus f equals 3e. Then we divide by 3, divide by 3, h minus f over 3 equals e. Question 7, standard form. The first number's got to be between 1 and 10, so we write 1.39 times 10 to the power. So the decimal point is here. That's 1, 2, 3, 4, 5 and 6 times 10 to the power 6. So this would be 5 times 10 to the power, we're going backwards, 1, 2, 3, so that's 5 times 10 to the power minus 3. Question 8, nice simultaneous equation here. I'll call that equation 1. The second one will be equation 2. I'm just going to multiply 1 by 2 because that will match the y's. So that becomes 6x plus 4y equals 30, 10x minus 4y equals 2. Write that nice and neatly underneath. So the signs are different, we can add these terms together line by line. That becomes 16x equals 32. Divide by 16, divide by 16. You can see x equals 2. Now sub x equals 2 into any formula to find the answer. So the top one is probably easiest. So 3 times 2 plus 2y equals 15. So we get here 6 plus 2y equals 15. Solve that by minusing 6, minusing 6. 2y equals 9. So divided by 2, let's go this way. So y equals 4.5. And that is quite easily done. Double check your answer to make sure you're correct. Well, 2 times 10 is 20, minus 4 times 4.5 is 18, and that does make 2, so we know we're correct. You should never lose marks on these types of questions because you can substitute your answer to make sure. Question 9. Work out the size of the angle ADC, so it's this angle here. Show you're working clearly. So I guess you will need to know a bit of circle theorems. If you have a tangent to a circle, those must be right angles because the radius is perpendicular. So that's 90 and 90. Angles in the quadrilateral is 360. So if we add 90, 90 and 74, that's 254. So 360 minus 254 is going to be 106. So this angle is going to be 106. That is step 1. Now they haven't asked you to give reasons, so it makes it a bit easier, but you need to know that the angle at the centre is twice the angle at the circumference. So this angle here is the angle at the centre, and it's double at the circumference. So angle D is at the circumference, so you just need to do 106 divided by 2 equals 53, and we are done. Question 10. Edna spends all her income on rent, on travel and other living expenses. So I'll keep this in fraction form. She spends 1/3 on rent, 1/5 on travel, and she spends 420 on other living expenses. Work out her income each month. So first, we need to work out what 1/3 add 1/5 equals. And so we find the LCM of the denominator, and that's going to be 15. So we're going to times top and bottom by 5 here, top and bottom by 3 here. So we're going to get 5 over 15, add 3 over 15, that equals 8 over 15. So that means she must spend 7/15 on other living expenses, and that equals, or as a ratio, equals 420. So that's, now it's like a reverse percentages question. So to work this out, we need to times both sides by 15, and then afterwards divide by 7. So 420 times 15 is going to be timesing that by 10, and then timesing 420 by 5, which is 2,100. That's 6,300, and that answer is 6,300. Now if it makes it easier, we can just say x here, because we're trying to find out what x is. So now we have 7x equals 6,300. So x stands for the original amount. So we just divide that by 7, divide that by 7. So x now equals £900, and that's your final answer. Now this question, you'll find a lot of indices questions now require some problem solving and thinking skills and understanding of indices. So this is really important to remember, because I've seen these types of questions appear a lot. 4 times 2x times 2 to the power x, we need that to equal 128. Now if you know your indices well, we know that that question is same as 2 times 2 to the 2x. That maps to this. So if we have 2 times 2, that's the same as 2 squared to the 2x. So when you multiply powers, you times them. So we can change this 4 to the power 2x to 2 to the 4x. So now this might be a bit easier to solve. So we have 2 to the power 4x times 2 to the x equals 128. Step 1, because now this is all in the same base, we need to know what 2 to the power what equals 128. So if you just count up in and multiply by 2, we get 2, 4, 8, 16, 32, 64, 128. You should see that's 1, 2, 3, 4, 5, 6, 7. So that's 2 to the 7 equals 128. That will get you a method mark on its own. So we know that 7 must equal, when we're multiplying these powers together, not in brackets, we add them. So this 4x plus x must equal 7. So we go 4x plus x. So we get 7 equals 5x. We divide by 5, divide by 5, and the answer is 7 over 5 equals x. And that should be acceptable as an answer. You could say that's 1 2/5, or if you know, that's just 1.4. And as you can see, you have to do this method because that is pretty hard to do mentally. So learning that skill and remembering this skill is important. So I would make a note of this question and try it again in the future, just in case you forget. Okay, question 12. This throws out people a lot because you're cubing everything in the bracket. So do remember what 2 cubed is. That's 8. So that's going to be 8e. We multiply the powers because it's in brackets to the 6 and f to the power 9. That should make sense because this is the same as writing this. So I'm just putting this here for understanding to why that works, and that's quite easy done. Expand and simplify. So I'm going to get 3x squared as the first term. Do the method. plus 9xy minus 4xy. Remember, we multiply the numbers, then the letters, minus 12y squared. What can we simplify? The middle. So the final answer is 3x squared plus 5xy minus 12y squared. Now, there must be a typo of this question. Find the value of k. I'm assuming this must be a times. So based on that, guys, we need to remember that root a is the same as a to the half. A to the power half. So times a to the 1. We're going to get at the top a to the 1.5. Now if we have a to the 1.5 divided by a to the minus 2, remember we minus the powers, and this is a common mistake. If we minus the powers when we divide, that's going to be minus 2, which you know should change to a plus. So that should be a to the 3.5 so a to the 3.5. So that means k must equal 3.5. Oh, D. That's a thinking problem type question. So how could you solve this? Now this is quite hard to spot, but remember, what is x squared to the minus 9 factorised? Because that's the difference of two squares. That is x plus 3, x minus 3. So that's the clue to this. So 2 to the power n minus 1 is the same as 2 to the power n plus 1 and 2 to the n minus 1. Now I'm going to try and explain why that works, because if you do 2 to the n times 2 to the n, the bases are the same, so you could say that's 2 to the 2n. Right, but if you bring this 2 down and multiply that out, that will become 4 to the n. If you multiply the squared out to the base, so that's 4 to the n. Hopefully that makes sense, and then the middle terms will cancel, so that would make that. Now, and I've written that wrong, like that, so be careful. So we should be able to see what cancels out. That would be this and this, and remember that doesn't equal 0, so that answer becomes 1 over 2 to the power n plus 1. And that was a cheeky little question that I imagine lots of students will fall down on that question. 13, a nice probability question. There are 20 counters in bag X, 11 of the counters are blue and the rest are red. So let's just fill that in first. Blue, the rest are red, so that must be 9 out of 20. There are 16 counters in bag Y, 9 of the counters are blue and the rest are red. So that's 9 out of 16 and 7 out of 16. Blue, red. Now there are different bags, so the numbers of counters doesn't change. That would be the same down here. Red. And is that, oh, that's quite a surprise. So part B, I was surprised if the question finished like that. Work out the probability that the two counters are both red. So we would need to do both red. 9 out of 20 times 7 out of 16, which should be 63 over 320. Obviously write that down here so you get your method marks. The two counters are both red or both blue, so we've got 63 over 320, so we need to plus those events, so both blue is 11 out of 20 times 9 over 16, 11 over 20 times 9 over 16, that equals 99. I'm going to just arrow that here, 99 over 320, so we've got to do 63 over 320, add 99 over 320 to get the final answer of 162 over 320. Now that is not too bad a probability question, but all the skills for probability are the same, so please make sure you can understand that and complete that. These questions normally always come up. So some of you use this formula to answer this type of questions. So frequency density equals frequency over the width. And that's all we need to do to draw this histogram. So 40, that's the width is 20 here, so 40 divided by 20 equals 2. 90 divided by 30, so the frequency density is 3. 140 divided by 50, just in case you can't do that, so that's 14 over 5, which is 2 4/5. And hopefully you guys know that is 2.8. If you're not sure, because 4 over 5 equals 8 over 10 equals 80 over 100, and that should make more sense. That's 2.8. That's 140 over 200. So let's write that here. That's 14 over 20, because we can cancel out those zeros. That's going to be 70 over 100, because if we times that by 5 times that by 5, and that's 0.7. And this one is 40 over 50, we know that's 4 over 5, so that is 0.8. So we just need to put those in. So 0 to 20 is 2. So that's 25 halfway, so that must be 20. That goes up to 2. Obviously use a ruler. And then you just fill all those in. And excuse the not very straight lines, do use a ruler. So now that's the histogram totally filled in based on the values you've worked out. Do use a ruler, get the scales correct, and that's pretty much one of the easiest histogram questions you can get. Let's look at question 15 now, guys. That's reoccurring decimals. So that means x equals 0.4363636 with the 3 and the 6 repeating. Now I have to look at this and think, what can we multiply x by? We need to simplify the fraction to 55 in the end, and we want the 3 and the 6 to repeat, so we're going to times x by 1000 to get 436.36 reoccurring. Now we need to multiply x by another value, and we want the 3 and 6 recurring, so we just multiply it by 10 here. So you get 10x equals 4.363636. And you can see we can minus that now to make 990x equals 432. Divide out by 990. Do that on both sides. Have nice clear working out. Leaves us with the fraction 432 over 990. And show that that equals 24 over 55. But that's enough for the full marks, just to state that fact, because it's only a 2-mark question. Now this is thirds, so we just multiply both sides by the square root of 3, top and bottom, not both sides. Now you can simplify the thirds first if you want to, but I'm just going to do it later. Depends, whatever's easy for you, but these numbers don't look too difficult to do anytime you want. So the root of 3 times top and bottom, remember to put the top in a bracket, so that becomes the square root of 60, add the square root of 240, divided by 3. Then we've got to simplify the thirds at the top, and because it's a simplify question, you know we're going to get similar thirds. If it helps, write the squared numbers at the side. Always easiest to find a bigger squared number that goes into the number, and it's quite easy to see for the square root of 60 it's going to be 4, so that's going to be the square root of 4 times the square root of 15 plus the square root of 16 times the square root of 15, because you know 15 times 15 is 225, so 16 times 15 must be 240. The root 15, like I said before, is a clue, likely to be in them, so that's a quick tip. Now you simplify the thirds now, so that's 2 root 15 plus 4 root 15, all divided by 3. Simplify the top, 6 root 15 over 3, and you can simplify the 6 divided by the 3 to get 2 root 15, and I'm just going to write that at the side so you can see that all very clearly. Well done. Now h equals fg here, and it's a functions type question. Now you might not have seen that before, but that's like saying hx equals fg of x. So essentially subbing g of x here into that x value here. So we start off with f, we've got 1 plus 1 over x. So we know fg is going to equal 1 plus 1 over, substitute g in, x plus 1 over 2. Now this is a reciprocal, so we should know that equals 1 plus 2 over x plus 1. If you keep flip those fractions, you will see that. Now I'm just going to write that clearly here. Now the inverse function, I like to do this in the method where I make x the subject. So I'll minus 1 on both sides to get y minus 1 equals 2 over x plus 1. Multiply both sides by x plus 1, x plus 1. So you get y x plus 1 minus x plus 1 equals 2. So we're going to get yx plus y minus x minus 1. Now that becomes minus 1 because you've got a minus and a plus here, so make sure you get that correct. So that equals 2. Now we want all the x's together, so rearrange that. So what happens is we get yx minus x, which is going to equal 3 minus y. Do the steps yourself and you'll see that. We can factorise that out. So we factorise x out to get y minus 1 equals 3 minus y. So divide out now by the y minus 1. So that leaves us with x equals 3 minus y divided by y minus 1. And that is the answer. And there's another way, alternative method you can do that. And this, learning this skill is considered advanced changing the subject as well. So you're practicing 2 skills at once here. That's not a bad 4 marks. Here's a graph y equals f of x. On the grid, draw the graph of y equals 2 plus f of x. 2's on the outside. If it's on the outside, it's going to translate everything up 2. So just use your 2 reference points. That's clear, that's up 2. Up 2. Use a ruler. That is a nice 2 marks. Here's a guy y equals f of x again, and it says draw y f of minus x, and it's in the bracket. So if it's in the bracket, it affects the x coordinates. And you always do the inverse inside the bracket. Now when it's a negative, you know it's a reflection, and if that's a reflection on the inside and we know it affects the x coordinates, then the reflection must be on this line here. So you just need to reflect that shape. This line will reflect to this line. This line will reflect up here. And that is the answer. Now, transformation questions, graph transformation questions, are generally quite easy. You just need to remember the language of transformations. Question 18. Show that answer. So this is just multiplying out triple brackets. We know that that's going to be x squared minus 1, so that equals x cubed minus x. Quite straightforward. Prove that the difference between a whole number and the cube of this number is always a multiple of 6. Right, this is an interesting one, because when we have x minus 1, x plus 1, this is exactly what we did above. When we expand that out, that equals this, and this is what the question is asking us. So this form here, so if you think about it, if x is any number, at some stage e.g. x equals 3, this section here will be x equals 4. So imagine this number turns into 3 times 2 times 4. Well, 4 is a multiple of 2. So essentially there's always going to be a multiple of 2. Hence, any multiple of 2 is a multiple of 6. Now, let's just choose an entirely different number. Let's say x equals 5. We can get 5 times 4 times 6 in this equation above. I'm going to show you, let's just choose x equals 10. We're going to get x, so if x equals 10, that's going to become 10 above times 9 times 11. Now 9 is a multiple of 3. You can see we're going to get a multiple of 2 here. And for this one you can see you've got a multiple of 2 and a multiple of 3. And 2 times 3 is 6, so it's always going to, hence always a multiple of 6. And you can try that for any number for x and you'll see that. And that's essentially the proof, I believe. That's all you need to do, but I've just written extra explanation so you understand it. And that is the end of the paper, I believe. Well, this won't appear in the exam. Now the sum of an arithmetic sequence can be written as this: sum equals the number of terms divided by 2 times a plus l, where a equals the first term, l equals the last term. So we know that the last term, l equals, is going to equal 999, and the first term is going to be 3, and when we're counting up in 3s, we're going to have 999 divided by 3, and that's going to give us 333 terms. So the sum is going to equal 333 divided by 2 times 3 plus 999. So that equals 333 over 2 times 1002. So that's essentially just going to equal, we divide up by the 2, 333 times 501, and work that out using whatever method you prefer, how you multiply. So 3 times 1 is 3, 0, 1, 5, add the 0, 3 times 1 is 3, 0, 15 again, add 2 zeros, 3 times 1 is 3, 0, 1, 5, let's add all those numbers together, 3, 3, 8, 6, 6, 1, so the sum equals 166,833, and we are finished. This won't be on the GCSE paper, let's make that clear. This is very easy if you know this formula, and you could probably work it out by just adding up the numbers, I guess. There's more than one way to do this, and I hope you're happy with that. And this paper is now finished.